So is it live now? Like I pasted the key.
ओके मैं देख रहा, एक मिनट। हाँ
Is it live?
हाँ लाइव।
Okay, so
आप
is it
स्टार्ट कर दो।
live now? Like I pasted the key. Okay, then I will start over. Hello everyone. So my name is Durgesh. So I will be taking today's PCD. So today it is a bi-weekly contest 173. So I will be explaining all the four problems. So the first problem is reverse string prefix. So the problem statement says that you are given a string s and an integer k. Reverse the first k character of s and return the resulting string. So it's like implementation. So there's no predefined logic for it. You just need to implement, like you need to reverse the first k characters. Suppose k equals to 2, we'll just reverse a and b, so it will become b a c d. If you want me to take an example, suppose I say I have a string a b c d. Yeah, I have a string a b c d, and I say k equals to 3. So my resulting string should be CBAD. So this is the first problem. So uh, how if you don't know how to reverse, you can just use two pointers and you can swap those indices, reducing it. Or else in C++, you have a reverse a substring option. So you just need to find the beginning pointer and plus k pointer. So these will reverse you the substring of k length starting prefix. So we will just return the answer. Yes, we can see. So we'll move to the next problem. So the next problem is minimum subarray length with distinct sum at least k. So I will read the problem first. So you are given an integer array nums and integer k. Return the minimum length of a subarray Just a second. Yeah. So you're given an integer array nums and an integer k. Return the minimum length of a subarray whose sum of the distinct values present in that subarray, each value counted once, is at least k. If no such subarray exists, return -1. So I will try to define the problem again. We are given an array, right, of length n. We need to find minimum subarray length whose distinct values sum is at least k. Question. This was the question, right? So this was the question. So we are given an array. We need to find the minimum subarray length whose distinct value sum is at least k. So what are the observations you can make over here is, let's create something like observations. Observations. Uh, the sum of distinct values should be k, right? At least or should be at least k, you can say at least k. If any subarray having distinct values sum, distinct values sum at least k, it is not one of the possible answer. Then we will choose the minimum among the subarrays. Minimum length, you can say, minimum length among the subarray. I hope this is clear. So we observed that if we can somehow find a subarray whose distinct value sum is at least k, so it is one of the possible answers. So among all those subarrays, we will find the minimum length. So this, you might think this seems to be a bit difficult, those who are not like never solved a problem in subarrays. So I will try to explain you with an example that would be much better. So we'll take this as example 22331 k equals to 4. Is like you guys are facing echo. Just a second. I'm not sure like what's the problem exactly. Why you guys are facing echo? So let me reconnect. So yeah, so
So
these
these
are the
are the
observations we
observations we
can
can
make.
make.
So
So
we'll
we'll
take an
take an
example.
example.
So
So
2231
2231
k
k
equals to
equals to
4.
4.
So
So
the
the
array
array
is
is
2,
2,
2
2
comma
comma
2
2
comma
comma
3
3
comma
comma
1,
1,
and we
and we
say
say
k
k
equals to
equals to
4.
4.
This
This
was
was
the
the
first
first
example.
example.
So you
So you
can
can
see
see
what
what
are
are
the
the
distinct
distinct
values
values
present
present
over
over
here
here
is
is
2,
2,
3
3
and
and
1.
1.
So the
So the
total
total
sum
sum
is
is
2
2
plus
plus
3
3,
5,
5,
5
5
plus
plus
1
1,
6.
6.
So we
So we
need to
need to
print a
print a
minus
minus
1
1
condition.
condition.
So
So
when it
when it
will
will
happen?
happen?
So
So
when you
when you
can
can
say
say
in the
in the
observations I
observations
will
I will
write
write
when we
when we
can
can
say
say
like
like
minus 1.
minus 1.
For
For
minus
minus
1,
1,
for
for
minus
minus
1,
1,
if
if
sum
sum
of
of
all
all
distinct
distinct
values
values
is
is
less
less
than
than
k,
k,
then
then
the
the
answer
answer
is
is
minus 1.
minus 1.
So
So
this
this
is
is
obvious
obvious
because
because
if you
if you
consider the
consider the
whole
whole
array,
array,
if you
if you
couldn't
couldn't
make
make
at
at
least
least
k
k
as the
as the
sum of
sum of
distinct
distinct
values,
values,
then there
then
is
there
no
is no
such
such
subarray
subarray
that would
that
have
would have
at
at
least
least
k
k
as
as
sum of
sum of
distinct
distinct
values.
values.
So
So
at
at
that
that
point
point
we'll
we'll
return
return
minus 1.
minus 1.
So if
So
I
if I
observe
observe
2231,
2231,
2231,
2231,
here you
here you
can
can
see
see
223,
223,
the
the
subarray
subarray
from,
from,
I will
I will
say,
say,
this is
this is
my,
my,
uh,
uh,
this is
this
my
is my
L.
L.
So,
So,
and
and
I'll
I will
just
just
write
write
R
R
over
over
here,
and I
and
will
just
just
place
place
this.
these things.
The
The
subarray
subarray
from
from
L
L
to
to
R,
R,
223.
223.
It
It
is
is
one of
one
the
of the
possible
possible
array
array
because
because
2
2
plus
plus
3
3
gives me
gives me
5
5
and it
and it
is
is
at
at
least
least
k
k
greater
greater
than
than
equal
equal
to
to
k.
k.
And
And
3
3
1 is
1 is
also
also
possible,
possible,
right?
right?
Because
Because
3
3
plus
plus
1
1
is
is
4
4
and the
and the
subarray
subarray
length
length
is
is
2
2
and
and
2 2
2
3
3
is
is
also
also
possible.
possible,
2
2
3.
3.
So the
So the
minimum
minimum
answer
answer
would
would
be
be
2,
2,
right?
right?
So
So
for
for
this
this,
the
the
answer
answer
is
is
2.
2.
But
But
how
how
you
you
will
will
calculate the
calculate the
minimum
minimum
among
among
all the
all the
subarrays
subarrays
is
is
a
a
good
good
question,
question,
right?
right?
So
So
if
if
you
you
know
know
what
what
is
is
sliding
sliding
window
window
or
or
you
you
have
have
a
a
like in
like
the
in the
previous
previous
or
or
whenever you
whenever you
solve a
solve a
question,
question,
if you
if you
ever
ever
heard
heard
sliding
sliding
window,
window,
you
you
might
might
feel
feel
that
that
this
this
question is
question is
very
very
simple
simple
because
because
we'll be
we'll be
using
using
that
that
approach.
approach.
So
So
initially I
initially
will
I will
keeping my
keeping my
L
L
over
over
here
here
at the
at the
0th
0th
index
index
and I
and I
will
will
traverse
traverse
through
through
the
the
array.
array.
So
So
while
while
traversing,
traversing,
if
if
I'm
I'm
if
if
my
my
R is
R is
at
at
some
some
particular
particular
point,
point,
let us
let us
say
say
at
at
this
this
index
index
that
that
is
is
2,
2,
if
if
I'm
I'm
able to
able to
calculate
calculate
the
the
distinct
distinct
sum
sum
between
between
L
L
to
to
R,
R,
then we
then we
can
can
figure
figure
out the
out the
minimum
minimum
length.
length.
So
So
how
how
can I
can I
find
find
distinct
distinct
sum
sum
is a
is a
question,
question,
right?
right?
So
So
is a
is a
question.
question.
So
So
the
the
thing
thing
is
is
we
we
need
need
to
to
find
find
distinct
distinct
sum.
sum.
But
But
how
how
is the
is the
question.
question.
So
So
if
if
we
we
can
can
somehow
somehow
find
find
distinct
distinct
element,
element,
then
then
we
we
can
can
find
find
the
the
sum.
sum.
If we
If we
can
can
somehow
somehow
find
find
distinct
distinct
element
element
between the
between the
subarray
subarray
L
L
to
to
R,
R,
then we
then
can
we can
find the
find the
sum.
sum.
This is
This is
very
very
simple.
simple.
So
So
when
when
you
you
say
say
this is
this is
distinct,
distinct,
when you
when you
can
can
say
say
2 is
2 is
repeating
repeating
2
2
times,
times,
but we
but
need
we
to
need to
only
only
consider it
consider
as
it as
1.
1.
So
So
we
we
can
can
keep
keep
track
track
of,
of,
I think we're getting echo, so let me try to use another earphones. My desktop audio is off. So, hello, can you hear me? Can you tell me like I'm getting echo or not? I'm not sure. No. So let me open the stream. YouTube, Codehurdle. Your voice is not clear. Is it clear now? Is it okay now? So yeah, great. Sorry for the disturbance. So yeah. So when we can say like if somehow we can find distinct sum, then the answer is done. We can find the subarray. But how can we find the distinct sum is the question, right? So if we can somehow find distinct element, then we can find the sum. If you can keep track of distinct elements, then you can find the sum. So like in LeetCode, there is a famous problem to find distinct elements in subarrays, unique elements. So I used the same approach. So what I did was I used a frequency map. So whenever before adding into the frequency map, I check before adding, I check whether it is in the frequency map or not. If it is not, then it is unique, right? If it is not, then it is unique. If it is there, then it is not unique, right? This is simple approach. So what I mean, suppose I start from here, I'll check the if I traverse from the array, I check in my frequency map. So here I will just keep track frequency map. Frequency map of 2 is what? 0. Initially it is 0, right? So that means 2 is not present. So I can just increment unique, right? I can just increment unique. So unique will be 2 now because I'm taking the sum, unique sum, right? So then I will just move forward to here. Then I can see here it updates to 1, right? Here it updates to 1. So I can see 2 is present. So I will just ignore this 2. I'll move to 3. 3 is not present. So if 3 is not present, the sum will increase. So it will become 2 plus 3, that is 5, right? This is the sum. But but I'm just increasing the R. I'm just finding the unique sums. But that's not our question. The question says that we need to find the minimum subarray length whose distinct value sum is at least k. So I need to increment this L2. So when I can increment L, when I need to increment L, we need to reduce the size of the subarray when the unique sum is greater than equal to k. That makes sense. Why it makes sense? Because the moment you get greater than equal to k, you can reduce this thing. So at this point, we got unique sum as 5 and k is 4. So you can just increment this L. The moment you increment, you remove this 2 from the frequency array, right? Initially it was 2 now, so it became 1. Then you can see the sum is still 5, but during this time we can keep track of R and L, right? So we can keep track of the minimum subarray length, right? So during this period we can keep track of the minimum subarray length. So among the possible subarrays we'll choose the minimum one. Then we'll just do this thing, and then we can iterate over R. R will go here. Then the sum is 4. This is also one of the valid pair. So whenever you see a problem, so understand the question first. If you understand the question first, try to find out the observations. See, we gone through the same question, we derived each and every line, and we concluded something. Like we concluded the for -1 condition, we concluded the minimum subarray length answer. This is how you find. So whenever you solve a question, try to analyze the things what you can get from the questions. This is some pure code, like pure logic you can find to solve any questions. You don't need to be like pro, or you need to be like know everything. If you can analyze well, you can observe well, you can solve questions without knowing it. So is this clear now? Question 2 is clear. Should I move to the code? Should I move to the code? So we'll try to explain the code. So what I took? So I took a map. Initially I kept a left pointer, that is L. So unique is the unique sum. Initially my subarray answer is, I kept it to maximum. So if I didn't find any subarray, just I can return -1. So what I did, so the same logic I applied. If any element is not present in the frequency map, that means the frequency is 0, right? That means it is a unique element in the subarray R to L. I mean L to R. So we can increment the value to our unique variable, right? So after that, I just incremented its value in the frequency map. Then I'm just incrementing L. Why I need to increment L? Because we need to find minimum subarray, right? If when I will increment L, whenever the unique sum is greater than equal to k. This makes sense, right? Because I told you here. I told you here. We need to reduce the size of the subarray when the unique element is greater than equal to k. Why we are reducing? Because we need to find the minimum subarray length. So how will you find the subarray length? That is I minus L plus 1. I'm considering I as my R. So it is I minus L plus 1, right? So if I increment L, I need to remove the previous frequency, right? So I'll just remove the previous frequency. If it becomes 0, that means this element is not contributing to the current subarray, right? So we'll just remove it from the unique sum, and you will just increment it. So when I can say my answer is -1 is when I didn't find any subarray, when this thing never happened, the answer would be -1, right? Or you can say sum of distinct values in the array is less than k. This is the same thing, right? Uh, any questions, or should I move to the third question? Any questions? Yeah. So I hope second question is clear. So we'll move forward to the third question. Huh. Third question says that you're given an integer array n, a 2D integer array restrictions, and an integer array difference of length n minus 1. Your task is to construct sequence of length n denoted by a0, a1, an. till an such that it satisfies the following conditions. So we're given a of 0 is 0, that's good. All elements in a sequence are non-negative. Okay, that means all elements should be 0, like greater than or equal to 0. For every index I till n minus 2, the absolute difference between ai minus ai plus 1 is less than equal to this difference. Okay, that makes sense, right? For each restriction I, you're given index and max value. The value at position index in the sequence must not exceed max value, that is a of index is less than equal to max value. Your goal is to construct a maximum valid sequence that maximizes the largest value. Okay. Within the sequence, while satisfying all the above conditions, return an integer denoting the largest value present in such an optimal sequence. Okay. So the thing is, we need to return the largest value. So I will be explaining the question again. So what are we given? Question 3. So we are given restrictions. Difference. Restrictions of I will have two values, right? That is index comma max value. The word says restrictions, but that means it is bounded with something. So a of index value should be less than equal to max value. This is the condition, and we are given a difference array of size n minus 1. This makes sense, right? Why it is n minus 1? Because we are finding adjacent difference, absolute adjacent difference, right? So difference of I is nothing but a base of a of I minus a of I plus 1. So what are the other things we are given? Third question, right? A of 0 is 0. We need to construct. So it is a part of question. We need to construct an array of size n. It should satisfy the above mentioned things. We know that a of 0 is 0. So we are given a restriction array and a difference array. Restriction of I says that we are given an index and a max value. It should be index, right? Index. A of index should be less than equal to max value. So we are bounded with something that is maximum value. We are given a difference array of size n minus 1, where difference of I equals to a base of a of I minus a of I plus 1. It is like adjacent difference, right? So we need to construct an array of size n. It should satisfy the above mentioned things. We know that a of 0 equals to 0. So what are we know? Like, if we need to construct something, we need to construct, right? We need to construct a. If we need to construct something, at the end, the output, yeah, I need to also mention. Output is the maximum value in AI, in A, you can say. We need to construct something. If we need to construct something, what are the things we know? We know that a of 0 is 0. So if a of 0 is 0, that means I can assume this is 0. The 0th index is 0. So I will write 0, 1, 2, 3, 4, 5. So we know it's 0th position, like at 0th position, the answer is 0. And these are some values, like I will just place dot, dot, dot. Or you can say some x value y z a b. So we need to find these values and we need to keep track of the maximum value in it, and we are bounded with some restrictions too. So we'll try to analyze how I can increase my answer, right? We try to analyze how I will increase my answer. So how will I increase my answer? So max value depends on what? Depends on what? This is the question, right? If we can find how max it based on the question, we know a of 0 is 0, right? A of 1 should be a of 1 should be difference of I, or you can say difference of 0 plus a of 0. Why I say this? Why I say this? Because let me go through an example that would help me better. You can like assume this as my example. So this is the difference array, right? This is the restrictions array. This is the difference array. This is the restrictions array. We know difference of 0 is abs of a of 0 minus a of I plus 1. A of 1, right? We know a of 0 is 0. Then difference of 0 is nothing but a of 0 abs of 0 minus a of 1, right? So difference of 0 is a of 1. If I substitute a of 0 as 0, then don't you think so? Difference of 0 will become different, a of 1 will become difference of 0, right? So we fixed two things. We fixed two things. But we can pre-compute those values, right? So the largest, so I hope this thing is clear. So we'll move to the next thing. So the largest max value will be, you will add the difference array. Max value equals to sum of difference, right? Difference array. Because a1 is difference of 0, then a2 will be what? A of 2 equals to difference of 1 plus a of 1. So at the end we are just summing up these values, right? We are just summing difference of 0 because a of 1 is difference of 0, difference of 0. This is the maximum possible value we can get. But we are bounded with some restriction, is that this particular index cannot be greater than this value, right? We're bounded with some max values. So this is where the question makes it tricky. But if somehow we can decode this well, the problem is very simple. So how we can decode this well? So we'll think blindly, like what are the things we know from starting. I told you that this is the maximum possible value, right? So the things we know is a of 0 is 0. This is the thing we know. So initially the array is 0, then some x, 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 right? So I will just simply copy this thing. I'll just paste it over here. This is restrictions, right? Yeah. So if I try to place like third index 0, 1, 2, 3. This value answer should be less than equal to 1. So less than equal to 1. This is the thing. This value answer should be less than equal to 1. Eighth index value should be less than equal to 1. So 1, 2, 3, 4, 5, 6, 7, 8. Since the n value is up to 10, so this value should be less than equal to 1. These are the constraints, or you can say these are the boundary for a particular index, or you can say a limit. So this is for sure. You cannot make this index greater than 1, right? And this is for also sure. You cannot make greater than 1. Then we can increment these values, right? We can try to increment these values. This is nothing but difference of 0. This value, since the next value is the absolute difference, a of 2 is nothing but a base of a of 1 minus difference of 0. This is one of the possible way, comma, a of 1 plus difference of 0. I mean, this thing is 1, right? Calculating for 2, so this will become 1. So you're saying, hey Durgesh, like I didn't get this point. Why it is plus difference or minus difference? So I will tell you, because we know difference of I is nothing but a base of a of I minus a of I plus 1, right? So what are the possible values we can get is a of I plus 1 can be written as a of I minus difference of I, or you can say a of I plus difference of I. So for a of I plus 1, either you can increment difference with the previous value, or you can decrement it with the previous value, right? So these are the two operations you can do for a of I plus 1. So judging which operation will lead to the answer is too difficult. In that place dp comes in place, but the constraints are huge. So n values is 1 if I write, sorry, n value is 1 if I write. So constraints are huge, so you can't perform dp over here. We can't perform 2d dp, right? Because there are two choices, so we need to think somehow the other way to solve this problem. This is one of the possible way. The thing is, it is bounded with some restrictions, right? It is bounded with some restrictions. Since we want to maximize our answer, the thing is we need to maximize a of I value, right? So how you can do that? So I told you 0 is the first index. We don't know these things. This value is less than equal to 1. We don't know these things. This value is less than equal to 1. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So we can compute this thing. We can compute this thing. But this thing should be less than equal to 1. So this thing should like all the above operations should differ. Either we can perform like difference of a of 1 minus difference of 1, or a of I plus difference 1. Like either we can subtract or we can add, right? These are the two operations we can perform. So how we can restrict these values is the thing. So initially we'll go through the restrictions array. So restrictions array will get two things, right? Restrictions of I is nothing but index comma maxval. So we'll try to place a of index equals to maxval, right? Maxval. This makes sense because this is the maximum possible value we can get. So we'll try to place a of index as this maxwell. So here it is 1 for me. Here it is 1 for me. Now this thing is sorted. The restrictions is sorted now. So let me go to the difference array now. I'll bring this to down. Let me go to the difference array now. So for difference of 0, a of 1 is difference of 0, so it will become 2. So if I increment this with 2, like if I increment this with 2, it will become 2. So next movement is I can just do, sorry, wait. How a of 2 is calculated? How a of 2 is calculated? I told you a of 2, how a of 2 is calculated. How a of 2 is calculated? Either you can decrement this with the difference or you can increment this. So a of 1 we know is 2. So the possible answer. Am I audible? Hello, can you hear me guys? Hello, hello. Am I not audible? Okay, got it. Okay, I will start. So why this is best? Since we want to increase our answer to the, like we want to increase our current maximum value, we'll try to perform this operation. So whenever the restriction condition fails, like this value becomes greater, so we'll perform a of 1 minus difference of 1. This is only applicable when this thing fails. If some value exceeds the limit, we'll try to apply these operations, right? So initially we'll try to apply these operations. Since 0 is fixed, we can fix this value. We can also fix this value. We can also fix these all values, right? So we'll try to fix. If I keep 4 here, the next thing I can do is I cannot make this as 7. Keep thing as mine. If I try to make this 7, it will just violate the constraints, right? It will just violate the constraints. So I will keep this as 1 only, because 7, 1 minimum of those two things is 1, right? And we need to keep the like we need to, at this position we need to reduce our value to a particular value. So all the element over here should be less than equal to the max value. The max value is 1, so we'll keep this as 1. Then over here it is like 1 plus 1, this will become 2. Then 2 plus 1, this will become 3. Then 3 plus 4, it will become 7. 7 plus 5, it's 12. Then this is 12 plus 1 is 13. But 13 is violating the constraints, right? So you need to place 1 over here. Then 1 plus 1, it will become 2. 2 plus 2, it will become 4. Am I audible now? Like, can you hear me? In between voice is not audible. Can you hear me now? Like, if you can just write in the chat. So we know these things is sorted. Some L to R is sorted, here it is sorted, here it is sorted. All these value are following the constraints. But now the thing is, we cannot make this as 12, right? Because 12 minus 1 would give you 11 and 12 plus 1 will give you 13. So from reverse will come. What do I mean from reverse is I will traverse from back side now. Suppose I'll just place my pointer I. This is my I. So initially I is my here. So the difference is 2. So I will check for this value. The answer would be, I'll try to explain what I did initially. So I was traversing from 0 to n. Okay, we fixed the limits for the restriction values, right? Restriction values. Then I was traversing from 0 to n. Since we want to increase our answer, what I was doing was, yeah, since I want to increase my answer, I'm doing a of I equals to a of I minus 1 plus difference of I. This makes sense, right? If I want to increase the answer, I will try to do a of I minus 1 plus difference of I. Could you please increase the volume? I think this is the maximum volume I can. This is the maximum value I can get. So now this is clear. But doing this thing every time won't be like, it is violating the constraints. So what I'm trying over here is, I'm not violating the constraints. How? I can just keep track of this thing, right? A of I comma minimum of those two things. If any case this thing will is greater than a of I, it will consider only a of I. This condition makes me fix the maximum value limit, right? So at the next point, if some a of I, let me copy the array so it would be better to understand. Yeah, so you can see, let me copy the difference array too. So here you can see, if you do 12 plus 1 you are getting either 13. If you do 12 minus 1 you are getting either 1. So I mean 11, right? So there is no way possible you can get 1. So in order to get 1, you can change this value. You can change 12. So how is the question, right? So a of I minus 1 should be minimum of comma a of I plus difference, I mean minus difference, right? Because why I'm performing minus? To decrement the values. I told you, if I want to decrement the value, I'll perform minus. If I want to increment the value, I perform addition, right? Why we are performing addition? To increase the value. Why we are performing minus 1, like minus difference? To decrease the value. So this makes sense. But in order to perform this operation, we need to traverse from n to 0. Why n to 0? Because we fixed 0 to n such that it gives us a maximum possible value. If you want to decrement something, this is the limit, right? So based on the limit, we can decrement this value, right? Based on the limit, we can decrement this value. If this thing changes, this can be also changed, right? At certain point, this will remain the same. So for this, if I perform a of I minus 1, it's with 0, then this is same. Now the thing is 0 minus 5 will give you the less than 0 value, so you'll just place it at 7. Sorry, I hope this is clear. So initially it was 12 for 0 to n, right? Am I audible? Could you please increase the volume? It is uh, this is the maximum volume I can keep. This is the maximum volume. So I'm not sure like how much you can hear me, but this is the maximum volume. Even I'm shouting. So I'm not sure. Wait, hold on. We'll perform plus obviously. Sorry. Because this is the limit, right? So if you perform 1 plus 1, this should be 2. Because you're performing minus over here. This is nothing but if you perform minus over here, this thing should be plus. What I mean is, if a of I minus 1, if a of I minus 1 minus difference of I gives me a of I, right? Gives me a of I. If this thing gives me a of I, then don't you think so? A of I minus 1. A of I minus 1 is nothing but this gives me the minimum value to decrement I. So don't you think so? Based on this condition, you can rearrange the numbers. A of I minus 1 is nothing but A of I plus difference of I. This makes sense, right? I told if you want to decrement it, when you will decrement if it violates. It is violating over here, so we decremented it. So this becomes 2. Now you can see 7 minus 5 gives you 2. So it will break over here. These things are sorted, right? 7 minus 2 gives you 7 minus 5 gives you 2. Is this clear? So should I move to code now? So see, what I did, I initialized a vector array, initially all value with long log max. So I know the fact that a of 0 is 0. Then what I did, for every restriction index, we kept its maximum value. So the thing is, it is unique. So all index are unique. So you can just keep this thing. I thought initially it is not unique, so it will work. So it's just like you are assigning the maximum value. This is the index, this is the value. So you are assigning the maximum value. So while I was traversing from 0 to n, I told you we need to increment those values, right? So a of I will become a of I minus 1 plus difference of I minus 1, right? So we're also keeping this as minimum because this thing should not violate. This is the maximum value you can get. So this thing should not violate. So we're keeping as minimum of a of I, comma a of I plus 1, I minus 1 plus difference of I minus 1. Then if some elements are violating, so what we will do, we'll traverse from n to 0. I told you in order to perform this operation, you will just if you rearrange this will become a of I minus 1 equals to a of I plus difference of I, right? This makes sense. Sorry, this is I minus 1. I did the same thing, so I got the array, then I took the maximum among them. So like if I run it, See, questions are simple if we focus on ourselves. If we can prove some things from the given things, it will become very simple. Initially, the question was seems to be hard because there are a lot of things given, restrictions, difference. If you can somehow solve those things and find some conclusions, the problem becomes very simple. So what we did, we analyzed everything. We analyzed the questions, we made some observations, we worked on the things we are given, like a of 0 is 0. Then we tried to fix some things. How we can fix some things? A of 1 is difference of 0, a of 2 is difference of 1 plus difference of 0 for maximum answer. Since we are bounded with some restrictions, we tried to figure out some things. So then we figure out this formula. This can be either plus or minus. So when it's plus, we added plus. So when it's minus, we added minus. So at the end, we got the array. We took the maximum among them. So this is how it should be, right? So I hope it's clear. So we'll move. Should I move forward to the fourth question? Should I forward to the fourth question? Fourth question is a bit interesting. Yes, no, anyone? You know what? Like people generally see these many things in the questions. Like if I say people generally see these many things, restrictions, difference, and some big values. So they will try to think, yeah, I can't solve this question. So if you can analyze some things from the given things, you can solve the code in a very simple way, right? This is something which was given in the question. We derived this thing. If we can derive this thing, we can also derive the minus one condition, right? Minus difference condition. So it's done. So you need to be good at observation things, right? You need to be good at observation skills. For each question, try to analyze the things you are given. If you can analyze those things, you can derive some things. If you can derive some things, you can derive the output. So every question is unique. So try to think all the possible ways and choose the best among them. That's what I do. So we'll move forward to the fourth question. So yeah. So let me read the question. You are given a string array grid of size n, where each string grid of I has length m. The character grid of ij is one of the following symbols. If it is a dot, the cell is available. If it is a hash, the cell is blocked. You want to count the number of different routes to climb grid. Each route must start from any cell in the bottom row, that is row n minus 1, and end in the top row, row 0. However, there are some constraints on the route. You can only move to one available cell to another available cell. The Euclidean distance of each move is at most d, where d is an integer parameter you given to you. The Euclidean distance between two cells r1 c1 r2 c2 is square root of r1 minus r2 whole square plus c1 minus c2 whole square. Each move either stays on the same row or moves to the row directly above. You cannot stay on the same row for two consecutive turns. If you stay on the same row in a move and this move is not the last move, your next move must go to the above move. Return an integer denoting the number of such routes. Since the answer may be very large, return it modulo 10 power 9 plus 7. Okay, so we'll try to think what we are given. I told you we need to observe some things. If we can observe some things, we can prove some things. If we can prove some things, we can derive the output. So what does the question says? We are given a grid size of n cross m. Each cell will contain two values, that is either dot or hash. This indicates, or you can say in string, this indicates cell is available, right? This indicates it is available. Hash indicates cell is blocked. We need to find the number of ways to reach at the top. You can say that is row equals to, so I can write something right, that is row equals to 0. We need to reach row equals to 0. We will start from row equals to n minus 1. If we want to reach, then we need to follow some rules. What are those rules? So what are those rules? So this is not the one. We are given an integer d. We can go to the cells. We'll try to write the main condition first. That is, we can only move to an available cell from another available cell. So this is clear. We are given an integer d. The This is the one thing. The second rule is the Euclidean distance of each move at most d. So I hope you know what is Euclidean distance. So for those who don't know Euclidean distance, so let me write it somewhere here. Is nothing but square root of, if r is the row, r1 is the another row, then it would be like their square. You can say r minus r1. I think it's present over here. So yeah, this is the Euclidean distance. So we can write in much easier way, right? So this is Euclidean distance. The distance from the cell, or you can say Euclidean distance, I'll write E distance from the cell should be less than equal to D, because we know that the distance should be at most D. That means it should be less than equal to D, right? This makes sense. Are we bounded with any other rules or what? You cannot stay on the same row for two consecutive turns. So what does this mean? We cannot perform the same move on the same row twice. This is what means that consecutive turns means you cannot perform the same move. That is, if you are at the row ith row, if you want to go somewhere in the ith row, that is counted as one turn. From there you are going to somewhere in the same ith row, that is counted as two. You cannot perform twice for the same row. You can say same row move on the same move on the same row twice. Yeah, this makes sense, right? So this was the question given to us. Seeing these things makes very hard the question, but the formula is just basic maths and some DP. So in order to solve this question, in order to solve this question, you should know DP. So for those guys, if you don't know DP, so it will be a bit difficult to you to understand. So if you know some basic DP, you can solve it, right? You can solve it. So how you will solve is the question, right? So we'll try to observe some things because very important thing is we need to be good at observation skills. Observations. When we can perform the moves or you and how many moves and how many moves. This makes sense.